Video, I'm going to go through the almighty Everest problem. As you are watching this video, make sure that you are taking Cornell notes, as you can see here on the screen. As you take notes, you are responding to these questions right here in yellow in the blue boxes that are provided to you. At the end of this video, I would like you to summarize what you have learned in just a few short sentences. This not only demonstrates to me that you watched the video, but it also gives you time to process and think about what you have watched. So for the learning objectives of today's lesson, students will employ multiple methods to find the y-intercept of a line given its slope and 1 point on it. They will learn how to solve for the y-intercept to find the equation of the line algebraically. So by this point, you guys have been exposed and have been talking a lot about slope in word problems, but I just wanted to take some time today to really slow things down, and so then that way you could go through a word problem piece by piece and then see how I extract information from it to build an equation and solve for slope. Okay, so as we're doing this, remember our jobs as mathematicians is to reason abstractly and quantitatively, as shown right here. We're also looking for and making use of structure, and what that means is we're looking for and making use of structure of what is in the word problem, so then that way we can solve for it. Okay, we're looking for keywords or phrases, and we're using what we already know from before about slope and y-intercept and other parts of the equation to solve for a problem. Okay, so let's go ahead and get started. So the almighty Mount Everest problem. Okay, so I'm going to go ahead and read the problem aloud. You can follow along with the words on the screen. As we follow along, feel free to pause the video, rewatch it, and take notes on your document that was provided to you. Okay, here we go. The Earth's surface is composed of gigantic plates that are constantly moving. Currently, India lies on a plate that is slowly drifting northward. India's plate is grinding into the rest of Asia. As it does so, it pushes up the Himalaya Mountains, which contains the world's highest peak, Mount Everest. In 1999, mountain climbers measured Mount Everest with satellite gear and found it to be 8,850 meters high. Geologists estimate that Mount Everest may be growing as much as 5 centimeters per year. Your task: assuming a constant growth of 5 centimeters per year, determine how tall Mount Everest was in year 0. The year 0 is the year that came 2,000 years before the year 2000. Write an equation for the height of Mount Everest over time, with x representing the year and y representing the height of the mountain. Then you're going to answer, what are the units for m and b in your equation? How many decimal places should be in your answer? Explain why. So, given this problem, okay, now what we're going to do, if you need to take a moment, pause right here, catch up on your notes. If not, if you're already caught up, let's go ahead and move on to the next part. Okay, so what information do we know about this problem? So I'm going to go ahead and take some notes right here. You're more than welcome to take these notes as well on your document. So what information do I know about the problem? So I know that if we go back to the top of this problem right here, we know that in 1999, mountain climbers measured Mount Everest with satellite gear and found it to be 8,850 meters high. So what I'm going to do is I'm going to go ahead and write that down. So I know that in 1999, the height was 8,850 meters high. We also know that geologists estimate Mount Everest to be growing as much as 5 centimeters per year. Okay, so geologists measure it to grow by 5 centimeters each year. Okay. We also know that that in this case what we're looking for, we also know from our previous knowledge that y equals mx plus b, and we know that we're working with this equation in this particular problem, but what we need to determine is what y, m, x, and b are going to represent. And they told us that x is going to represent the number of years, and that y is going to represent the height of the mountain. Okay, so one thing I want you to observe in this problem is that we know that it's growing by 5 centimeters each year. Okay, but what they're asking for, okay, or what they've told us is that it's 8,850 meters high. So they're talking about meters here. So we do have a discrepancy in the measurements where we're comparing meters to centimeters. So we probably need to convert centimeters to meters. In this case, 5 centimeters equals 0.05 meters. Okay, and if you need to, or if you need me to clarify that, I can. Just ask me outside of class. Okay, so we know that 5 centimeters equals 0.05 meters. We also know that m is going to represent some sort of rate of change, and that b is going to represent the initial value, or in this case, the initial height. Okay. Now keep in mind that what I'm solving for, okay, or what I'm trying to do is we're trying to write an equation, and actually let me erase that. We are trying to write an equation for the height of Mount Everest over time with x representing the year and y representing the height. Okay, so given this information of what I know, okay, given what I know, I'm going to go ahead and start determining what not only this initial height is, but I also need to discuss my rate of change as well. So let's go ahead and start filling in the equation with that information. So again, remember I have y equals mx plus b, and so far I know that it grows 5 centimeters per year, or in this case 0.05 centimeters. Okay, so that's the rate of change. Okay, I know x is the number of years, b is my initial height, which we don't know, and then we know that y is my current height. Okay, so in reality, what I'm going to do, let me go ahead and make this smaller. Okay, I'm going to go ahead and make that smaller. So in reality, what I also know is that if I start substituting in what I know that we have, let's see, let's go back to the top because Miss Tomlinson even forgets sometimes. So we know that in 1999 it was this many meters high. So I'm going to go ahead and substitute that in. I have 8,850, and I know that the rate of change was 0.05, and then the year was 1999. because remember, our rate of change doesn't change. Okay, and then I get my initial height, which is right there. And the reason I'm not substituting a value for b is because I don't know what b is. I don't know what my initial height is. But what I do know is that in 1999, the height of the mountain was 8,850 meters. Okay, so now my job is to solve for b. So I have 8,850 equals, and in this case, I need my calculator. So let me go ahead and substitute this into my calculator. That's 99.95 plus b. I'm going to subtract that to the other side. I get b equals 8,750.05. Okay, so that means that my initial height is 8,750.05 meters. Okay, so since my initial height is at 8,750 meters, if we were to look at that on a graph, okay, so here, right here, this is 0, 0 height. Remember, my height is in years. My height is in years here, and my x is in years. So this is x and this is y. And then here I have the height. Okay, so if this right here were, so let me go ahead. If this was, let's say, for example, we're just going to go ahead and call it this. I'm going to modify the scale of the graph just a little bit. Let me go ahead and let me write that a little bit better. 8,750.05. And then let's say up here, this is going to be 8,850.05. So right here, this is the year 2000. Okay, my height, remember, because I had an established height at year 0, my height is going to start right here. And then at the year 2000, it's going to grow by, in this case, 100 meters. Okay, so 2,000 years later, it has grown by 100 meters, or in this case, 1,000 centimeters. Okay, so at the end of the day, or at the end of all this, so let me go ahead and I'm going to insert I'm going to add a page to the bottom. Let me go ahead. Okay, so at the end of all this, my final answer is going to be y equals, and then for my m, I still have 0.05 x plus my initial height of 8,750.05. Okay, so this means growing by 5 centimeters per year. And this is the initial height of Mount Everest. Okay. Now you're probably wondering, Ms. Tomlinson, how did you get this value right here? How did you know that it was this value at the year 2000? That's a great question. So now I have my formula. I can go ahead and say, well, if I want the year 2000, I'm just going to go ahead and substitute that in for x. Oops. when I substitute it in for x, I'm going to get y equals 8,850.05. Okay, so I can also do the same if I wanted to find my initial value as well, if I needed to, for year 0, and I know that at year 0 this was the height. So that's how I can find my initial, or my points here on the graph. Okay, so that's essentially what it means. Now remember, you do still need to go back up to the top, or I'm sorry, not up to the top, but we also do need to find what are the units for m and b in your equation, right? Or, I'm sorry, let me rephrase that. We still need to determine how many decimal places should be in your answer. Well, the reason is we know that we're going to go 2 decimal places because we're measuring in meters, not centimeters. So we know that we are measuring in meters, not centimeters. So we only want to go to decimal places. To the right. Okay. So if at any point you needed to go back or re-listen or re-watch the video, now is the time to do so. Oops, my bad. Okay. And then what I would like you guys to do from here is also just remember to go back and fill in, to fill in your chart. Okay, so to go back and fill in your Cornell notes. If you guys have any questions, please let me know. And that's about it. Thanks for watching.